Hello, and thank you for watching this snapshot of our research on congenital diseases in harbor seals from the Salish Sea. Before I begin, I would like to acknowledge and thank the indigenous peoples of the Salish Sea whose natural resources, land, and waters we have accessed and studied during this research. Today, I will be presenting work that my co-authors and myself have recently published in the Journal of Wildlife Diseases. So what are congenital diseases or defects? Well, they are structural or functional abnormalities which are present at birth. There have been previous reports of a number of defects in harbor seals throughout their range, which extends across the coastal regions of the Northern Hemisphere. In many other species, such defects can be associated with maternal toxic or pathogen exposure, genetic defects, malnutrition, disordered embryonic migration, or fusion. While cases have been noted throughout the Salish Sea, an epidemiological assessment of cases had yet to be conducted in order to assess prevalence or potential causes, so we set out to do just that. We found all cases noted between 1985 and 2020, and then we determined whether these necropsy cases could be confirmed as apparent defects at birth. Therefore, we had 27 confirmed cases. As you can see from the map, the cases were widely distributed throughout the Salish Sea, though through spatiotemporal cluster analysis, we didn't find any significant clusters, either spatially or temporally. We did have a number of cases with multiple defects, and the most common defects that we found were craniofacial, heart, brain and skull, or dwarfism. So let's go into it. The most common were craniofacial malformations, most often in the form of cleft palate and lip, as seen in these three cases. These are seen by a missing portion of the soft or hard palate or lip, leading to an airway change or malformation. Another type of congenital defect we found was dwarfism. This image compares a case of dwarfism on the top to a typical harbor seal pup on the bottom. As you can see, the pup with dwarfism has a diminutive head, which is usually of smaller and shorter shape with a shorter snout, and they also had disproportionately short and malformed flippers, and a shorter and rounder body type overall. The two extreme cases of brain and skull malformations that we noted both included a reduction in overall brain mass. This image shows the most extreme case, where there was hardly any brain tissue present, and there was an excess of CNS fluid upon opening of the skull. The only tissue left was a small bit of cerebral cortex, seen by that arrow, and a small bit of brainstem by the other one. To assess whether the cases we identified were more or less prevalent on a yearly basis, and to determine if a sentinel population could be used to monitor for regional trends going forward, we compared the yearly prevalence of all cases in the Salish Sea with cases at Gertrude Island, which is a frequently monitored and thoroughly researched rookery in the southern Puget Sound. The average yearly prevalence within the Salish Sea overall was 2.9%, and at Gertrude Island was 3.1%, and this was only of necropsied pups. It's important to note there was never more than a 7% difference observed between the two, and we believe this is likely due to sampling bias overall. So from this, we believe that Gertrude Island is an excellent sentinel population for surveillance of birth defects in harbor seals within the Salish Sea. So what does this mean for the Salish Sea ecosystem? Well, we believe that the 2.9 prevalence observed in this study is likely the endemic level of disease in the Salish Sea yearly. So if that is to increase, then that'd be worth monitoring. We also found that a sentinel population such as Gertrude Island is an excellent tool for monitoring in the future and should be employed whenever possible. We could not identify any underlying causes related to multiple diseases in this limited data set, so we suggest further study to require robust testing for toxicology, nutrient deficiency, and potentially even genetics. Finally, I just want to say thank you and acknowledge all of my wonderful co-authors and collaborators for all their help and support, as well as some special people at Fish and Wildlife and Cascadia, as well as the Whale Museum and our funding agency. Thank you.